Hi everyone, and welcome back to another Math Club video. Today, we will be going over question 21 of the AMC10 of 2018. The question asks, which of the following describes the set of values of a, for which the curves x squared plus y squared equals a squared, and y equals x squared minus a in the real xy plane intersect at exactly 3 points. The first thing we need to recognize is exactly what these equations represent. If you've taken any algebra course, you would know that x squared plus y squared equals a squared is the equation of a circle of radius a centered at the origin. And y equals x squared minus a is a parabola with the vertex a below the origin. The graphs would look something like this. So, obviously, these two graphs must intersect at the vertex of the parabola and also the lowest point on the circle. This is because both graphs contain the point 0 minus a. If we try to overlay the graphs like this, we can see by inspection that the graphs only intersect at 3 points if the curvature of the parabola at the vertex is greater than the curvature of the circle. So, how do we find curvature? We can do this by finding the second derivative, or d squared y over dx squared. To find the second derivative, we need to employ a technique called implicit differentiation. This is because the equation x squared plus y squared equals a squared is not an explicit function, meaning that it's not y equals something. It's an implicit function, so therefore we need to use implicit differentiation. How this works is we differentiate both sides with respect to x. So how we evaluate this is that we first differentiate x squared with respect to x, which is just 2x, but then when we differentiate y squared with respect to x, we have to use the chain rule. We do this by taking 2y times the derivative of y prime, or we can write it as dy dx. Since a squared is just a constant, the derivative of a constant is always 0. To find the second derivative, we can implicit differentiate again on both sides. The derivative of 2x becomes just 2, and we have to use the product rule to differentiate 2y dy dx. So first, we can take out the 2. Next, we have to differentiate the left side first. So we get dy dx times dy dx. Then we differentiate the right side, plus y d squared y over dx squared. This is because the derivative of the first derivative is the second derivative, and all of that is equal to 0. Next, we have to figure out what dy dx is. So we can solve for dy dx using the top equation. From here, we can see that dy dx is simply just equal to negative x over y. Finally, we can just plug in negative x over y here and solve. We get 2 plus 2, x squared over y squared, plus y d squared y over dx squared, all equal to 0. Doing some simple algebra, we get x squared over y squared plus y d squared y dx squared equals negative 1. And then d squared y over dx squared equals negative 1 over y plus x squared over y cubed. Next, we need to find the derivative of y equals x squared minus a. This is very straightforward, as this is an explicit function. We take the first derivative, dy dx, and then the derivative of x squared is just 2x, and derivative of a constant is 0. Then, to take the second derivative, we'll get d squared y dx squared equals 2. So now we know the second derivatives of both of these functions. Now we have to go back to what the question is asking for. If you recall from the beginning of the video, I said that these two graphs would intersect at exactly 3 points if and only if the curvature of the parabola, so d squared y over dx squared parabola, is greater than the curvature of the circle. At the point 0 minus a. So how we go about doing this is to just evaluate these two second derivatives at the point 0 minus a. We can do this just by plugging in 0 for x and negative a for y. We see that the first term is 1 over negative a, and the second term just cancels out since x is 0. We get 1 over a. For the parabola, we see that since this is just a constant function, evaluating at 0a makes no difference, and it's still just 2. So all we have to do is just compare these two. So we get 2 is greater than 1 over a. Solving for a, we see that a is greater than 1/2. And that is our final solution.